Hi everyone, welcome to this new video, which I'm going to describe how to use Velociraptor at scale to do some hunting um, with lots of endpoints. And previously, in previous videos, you've seen how we use Velociraptor to hunt for various indicators across our network, but we haven't really shown how it works at scale. I mean, I sort of said that it's really a tool that's designed to work at scale, but we haven't really shown that. And so I thought I would make a video today where I would actually show you guys how I can run Velociraptor on many endpoints and then do the very large scale hunts. And we can use that to actually demonstrate the analysis process of how do we actually detect anomalies very quickly across a large network. So I wanted to use a very large network, and I actually wanted to use around 5,000 endpoints. And I didn't really want to use a real network, uh, for privacy reasons. And I just also wanted to show you guys a quick a tool that we use to test such a large network. Uh, as you know, Velociraptor is really designed to work at very high scale. And so what we really want to do is we want to be able to simulate a large number of endpoints so that we could actually see how the server is behaving under very high load. And we have this feature here called the pool client. And we use that for development in the development team, but I mean, you guys can use it as well at any time, and just to get a feel of how does it actually look like to work with a very large network. And so all you have to do to actually run it is just like running a normal client, except you run what's called a pool client. So a pool client is just the same as a normal client, except instead of starting one client, it will start as many client as you've determined, right? So let's say 5,000. So when I run this command, it will actually create 5,000 new clients, and they will all be pointing at the server, at the same server. And I can do that on one machine and essentially emulate a large number of clients from the same machine, so that the server looks like it's being used by 5,000 separate machines. But in fact, they're all exactly the same because they're all running on the same machine. So let me just demonstrate how this works. So I'm just going to run this with this command, and you'll see that um, it will start off and it just starts increasing the number of clients and creating more connections to the server. And these are actually each one of those is like a separate client. It's a whole separate client with its own communication protocols and its own connections and its own cryptographic keys and so forth. Um, so it will take a few seconds just to bring up 5,000 clients. And I'm going to use this Windows machine here as the platform to run on. So all of these clients, those 5,000 clients, are really actually the same machine, right? So when we are going to run hunts and so on, I'm actually going to be interrogating this very machine. So they're all going to be the same pretty much. But as far as the server is concerned, there are completely different clients, and they just run separate. They're completely separate, right? So when we are actually going to do the hunting and actually look at all the data, then it would appear as though uh, those um, those things are really it's pretty realistic, right? We're going to have um, a realistic experience here. I've also got another VM here which actually has, so this is a clean machine, and my other VM here actually has a another single client running with um, one kind of test from the attack matrix using a typical. We're going to look at scheduled tasks, so actually has a malicious scheduled task, and I'm going to show you how the UI actually facilitates being able to hunt for this particular anomaly amongst these 5,000 clean machines. How can we actually just quickly, detect that one machine that's compromised? So after I started this, it basically fired up all of my 5,000 machines, And then as you can see, the CPU load is flatlining because now all the machines are basically initialized and they're ready to go. All those clients. This is just a typical VM. It's not particularly powerful, but this is pretty optimized in order to try and exert as much pressure as possible on the server, so we can emulate um, the, the server. The server is actually similarly spec'd to this one. So that's the Windows machine. So let me just minimize that, and I'm just going to have a look at my Velociraptor instance. And now when I just click show all, let me just maximize that a bit, then I can see all of these machines, and there's going to be 5,000 separate machines, but they're all actually the same. And you can see that the pool client is actually just creating these sort of machines. It just kind of adds a number on top of the host name, and they're all exactly the same because they're all actually the same machine. But for Velociraptor, they all look completely different because they have separate client IDs, and so they look completely different. It just looks like a really, really large fleet of 5,000 machines that we could actually just page through. But of course, they're all going to have the same specs because it's exactly the same machine. But one of these machines is going to be the one with the needle in the haystack that we're going to find in this case. So it's not, what I'm going to do now is just not a particularly complicated. Let me just show you the dashboard here, and you can see that with the dashboard, we've got like 5,000 current connections, and then it's going to go up to that in a minute, and then we will see the full thing coming up. Okay, so what we're going to do is we're just going to hunt for scheduled tasks. This is just an example. It's not a particularly complicated example from the attack matrix. So we can look at each of these machines separately. So we can interrogate each machine. We can collect individual artifacts from these machines. We can select new collection. We can grab the scheduled tasks. Just going to search for the right artifact, get our task scheduler, right? And when we launch it, it's going to just collect the task scheduler from that very machine, a single machine, right? And we can see that it's basically going to go off and look at the different scheduled tasks. And if we look at the results over here, then we'll see, this is just all the scheduled tasks that it parsed, from the machine, from the endpoint, right? So these are all the commands that are going to start up, and so on. We actually can look at the full XML here, and just hide all the other ones. So we can actually, look at it if we wanted to. But the artifact tries to extract, the main parts out of it. So this is kind of what we want to do, but we want to do it for all 5,000 machines at the same time. So what we're going to do is we're just going to do what's called a hunt. And a hunt is basically when we collect the same thing, the same artifact, from all of our machines at the same time. So it looks exactly the same as collecting it from individual machines, except that we're going to do it for all the machines. So let's create a hunt. We'll put a description in there. So we'll go to collect scheduled tasks, and we can choose where to run it and so on. But we're just going to run it everywhere, and it's the same thing. We're just going to create the same artifact. We're going to search for the scheduled task. There it is. It's going to look for tasks in this directory and just collect them all. We can configure the individual parameters. So we can change the directory, but you normally wouldn't. And we can grab the actual files, but we normally wouldn't. If it's a very heavy artifact, then we can make it go a little bit slower or take a little bit longer or whatever. But this looks pretty good. So we can just hit launch, and this will create a new hunt. And as you will see, it will start in the paused state. So when it starts, it isn't actually running at the moment. So what we're going to do is we're going to basically press this play button and run it. And what that will do is we'll start to schedule this hunt on all the clients. And you can see the CPU is starting to tick over now. As these tasks have been scheduled, and we're going to schedule this from all our 5,000 virtual endpoints sort of thing. We should see this number start to tick over here. There we go. So we can start to see this number going up. So 500 machines got scheduled and 2,000 and so on. Like it's basically scheduling them all at the same time. And as it's running, these machines are starting to return results. So the clients are going to start to return results. Now, of course, in this case, it's the same. It's going to be the same result from because they're all identical virtually. But in the real world, this will be each of them will be a separate result, right? And in this setup is specifically designed to be as realistic as possible. So it really is performing exactly as it would in the real world if I had 5,000 actual different machines, because each of them is separate network connection doing exactly the same thing. So it's going to take a short time for the server to collect this data. But as this is happening, we can take a look at the clients tab here. And we can see how the results are coming back. And these are basically all the collections that are scheduled. You can see these are called flows. We call it in Velociraptor terminology, they're called flows. So they have a flow ID. These are all the different host names that are scheduled. And, and we can sort of, we can browse through that. There's, we can go all the way to the end. We can go all the way to the beginning. There's going to be 5,000 scheduled machines. And so we can see actually how each of them are going. You can see some of them are finished, some of them are not. So they're kind of coming in at different times. And the ones that are finished, we can click on this view here. We can see what happened. This is the logs of actually what happened. And we can see that it returned 197 rows. And then we can see those rows for this particular machine individually, right? But the hunt essentially runs it for all the machines in the same time. Okay, so if we look at the overview, these results are coming in pretty quickly. And in a few seconds, we will finish all of the entire fleet. And so we would have already collected all of our results. So when you actually think about it, how many actual rows of data did we get? You can see that there's maybe about 200 rows per machine, because I mean all of them are identical in this case, but there'll be some variations in real life. And we can see we've collected. There's going to be 5,000 machines, so we're looking at about 1 million rows. So it's a pretty significant data set that comes back of all these different tasks scheduled on all the machines, right? This is like a pretty big hunt. So so now the hunt is finished, right? So we can actually now look at analyzing the results. Now, previously, in previous versions of Velociraptor, we didn't really have much of an analysis type UI. So the only thing that we kind of could do after doing this kind of hunts is just sort of export the data. So I could have gone here and maybe I create like a CSV file here. As it turns out, this is a pretty large hunt, right? So this CSV is going to spin here for quite a while. I'm going to leave it here just to show you how big the zip file is going to be. But essentially, this zip file is going to create a big zip file with the CSV file in it of the entire result set, right? Of all the clients, from all the clients, and it's pretty big, right? It's going to have about 1 million rows, and it's going to be quite large. So and so once you export that, then how do you actually even process it? It's going to be hard. Like you can't load it into Excel because it's way too big, and then loading and processing and post-processing, it's pretty tricky. So what I'm going to show you guys now is the new notebook feature in Velociraptor that allows you to post-process these very, very simply. And so now we can actually hunt for the malicious task very quickly. So you would have noticed a new tab that's been added to the UI in the last release, 053. So if we have a look at that, this is a notebook tab. And we used to have, and we still do, we have notebooks section here where you can just create like general purpose notebooks. But now we actually create a notebook automatically for every single hunt, and in fact, every single artifact collection that we do. And because this is just, now it's going to be the way at which we can post-process the results, and it's going to make it a lot easier for us to post-process the results. So as you can see, the notebook is essentially a way for us to just have like an interactive. You can actually also share it with other users, and so we can actually now start to build kind of a story here, and you can see that this is the markdown, cell. So I'm just gonna describe what I'm doing. I'm gonna be looking for hunt for malicious scheduled tasks. All right, so this is going to be my title. So now I save it. It's basically now updates the notebook. And you can see that by default, when it first creates the notebook for this hunt, then it creates it with there's already a table, and you can see the data is already in there, but it's essentially VQL. And the whole analysis part here is around writing queries so that we can actually process these queries, these post-process these data using VQL. So if I just click the edit cell button, then I can see the VQL and I can see what it's doing. You can see that it's essentially getting all the hunt results for this particular hunt, and then limiting it to 50. It just gets the first 50 rows by default, because remember, it's a massive result set here. And it's just going to show us like roughly what we've got. But now we are going to have a look at exactly what we're going to do with that. So typically, we want to post-process these results. So most machines have legitimate tasks, scheduled tasks that run, and there's a whole bunch of legitimate ones, and some of them are going to appear on many machines, and some of them will be quite unique and maybe suspicious. So usually with this kind of analysis, what we want to do is kind of stack it. So we want to stack the result set across all of our 5,000 hosts. And so what we really want to do is we want to do a group by, and we just want to group by this command field, right? And we want to generally count as total count, let's say. And so we're just, this VQL simply adds another field, which is the count, and we're just going to group by this command. So essentially, it's going to run through, and it's going to basically add up each individual command and count how many times it appears. So it will tell us which ones are the commonly used ones and which ones are less commonly used. Now this query is going to be absolutely huge. As we said, there's about 1 million rows in here. It's going to take a couple of minutes to do this. So off we go, right? So it's going to take some minutes. Now, VQL is not really a database. There isn't really a database. We don't use a database here. So it is actually going over the 1 million rows result set and figuring it out. And because it has to do a group by, it essentially has to look at all the results before it produces any rows. So it's going to basically take the full time here. Let me just hop over here to show you. Oh, this is still going. Okay, so we're still exporting it. That's how big the result is. We'll see how big it ends up being. So once we do that, let me just copy this again. And whilst this is doing this, I can start to calculate something else, right? So I can continue on with my analysis. I don't really need to wait. So I'm going to add another VQL cell over here. And in this one, I'm just going to look at so again, we're just going to look at the first 50 rows, right? And this will show us roughly what things are. And a fairly common one is that maybe you know we're going to have some cmd.exe or PowerShell is going to be our command here. So we can actually filter it straight away with all the commands where where command matches. This is our regular expression operator matches cmd.exe, and that will show us all the commands that are actually running from that run command shell or PowerShell or something like that. PowerShell. Okay, so we can maybe limit it a little bit just to see whether that makes sense, and then just run it along. And the same sort of thing is going to happen. Again, this query will again also pass over the entire result set and produce some results. So we'll just wait a little bit and see what's going on. Now, if we just if we're not getting any rows and the queries, we can always cancel it. So we can cancel it. So well, we're just waiting for this thing to complete for our stacking. We'll just cancel it. Okay, so you can see that this summary is now exported. This is the old way of doing this. We would have to get the zip file, and it's exporting it into, that's 120 megabyte zip file. And then I would have to download it. There you go. And it's a zip file. I'll open it, and you can see inside of the zip file there is a CSV file. And just to give you an idea, the CSV file is 1.5 gigabytes for one CSV file, right? It's absolutely massive. And so actually post-processing something this big is just crazy. It's very hard. And some people actually forward that to something like Elastic or Splunk or something like that to actually get this kind of post-processing. But it depends on what you're doing. You might, if you need to frequently query this data, then that sort of makes sense. But a lot of the time, just it's actually slower to export it and then query it for fairly simple queries that you sort of know in advance. Let me just go back to the notebook. So here's this group by is finished now, and so we can see. Let's just turn off some columns in the UI because some of them are not so important for us right now. So we're just going to just maybe just turn some things off so we can see a little bit better. So you can see that we have the total count. This actually makes perfect sense, as you know, from what I explained before with the our Windows machine has the pool client, which is 5,000 machines, but they're all exactly the same. So they're going to have, the same commands because it's just going to repeat the same thing 5,000 times, right? So we can see, okay, so when we stack it, then we say, okay, this defrag is running actually twice per machine, so it's going to be 10,000 and so on. But what we actually want to do is, we want to get the ones that are, less common. Let me just get rid of that. So you might think at this point, oh, actually, I actually wanted to order it, but I forgot to order it, and so now I'm going to have to wait, another couple of minutes to do this whole calculation again. But no, this doesn't actually. You don't actually need to do that because this group by is only 58 rows long. It's very quick, right? So really, all I want to do is just order this. I don't want to change this table. So if I go over here and I click add cell from this cell, what does that actually do? So you can see that it creates a cell below that looks the same as the last one. But the VQL is basically says, oh, grab this cell above us with this cell ID and just select it, right? So it just reads that same data again. So now I can simply do order by, right? And then have a look at the column. It's going to be called total count, right? Total count, right? And this is a very quick query because it's just looking at 58 rows, right? And then it's going to basically order it. Let me just hide some of the less interesting less interesting field so I can see the total count. Here, there it is. Actually, probably don't care too much about that moment. Okay, so you can see here, that's the command, that's the argument. And we have a whole bunch of commands here that are only present on one machine instead of, 5,000. So these are like less common. And now I'm in a position to go and look at them more closely. And so, this is, calc.exe. It's obviously bad, right? So, so now I can say, oh, okay, this calc.exe is actually suspicious. And that is in fact the atomic red team test that I ran on this machine. And so now I want to know which machines have this calc.exe on it, because I know there's only one really. And actually, so I know there's only, it's going to be this one, right? But, maybe if I have 2 or 3 or 4 of those, then I want to check whether all of the machines have that calc.exe. So I can just now go and add a VQL cell. So just copy this query here, copy, and add a VQL cell, right? And again, this query just looks at the results of all the hands. And what I'm going to do is just filter it where command is going to be calc.exe. And so now it will still take a long time because it will basically check every row, which we have approximately 1 million rows, 1.5 gigabyte CSV file, right? It's huge. But it should then retrieve the right hit. It will take a few minutes, but it will just show us all the machines that have calc.exe on it. So typically, this kind of investigation happens when when you have like ransomware or cryptoware or something like that, and they will install backdoors, in all the machines that are actually compromised in the network and laterally move across the network, and you have a whole bunch of machines that are actually compromised in a similar way. So once you identify your malicious task, then you can just essentially filter for all of the all the bad tasks. So this is cool. So now we are going to explain what we've done, show our work, stacking across the entire deployment. Okay, so grouping by all the machines, but grouping by the command and counting. Okay, so this explains what we've done. So we show our work. So this is going to be this table. And then over here, we're going to add another markdown cell. Then we can say, what have we done here? We sorted by command count, looking for less common commands. Right? So now we know what we've done, sort of thing. And you can see that by default, it's got a lot of fields in here. And because this is a quick query, then I can just filter it straight over here. Commands, arguments, and what other fields do I want? Fully qualified domain name and total count. Fully qualified domain name and total count. So when I run this, it's going to basically give me fewer results. And in fact, I know that the 5,000 results I'm not really interested in. So I can even just get rid of those where total count is less than 200, let's say. So that just shows me spelled it wrong. Yeah. So that just shows me those fairly unique jobs that are running only on one machine instead of lots of them. So this is fairly unique. And so you can see, and here this guy's already finished now. And so I've got, this is our atomic test that was running on this machine. So we know that this machine has been compromised. So now I'm pretty happy with this, right? So I want to export my report. That's great. So I'm going to click on this button here, export notebook, and I can create a HTML page like this. So this is going to give me a HTML report. Download it, open it, and it's basically just, the tables. This is going to be all 58 rows. You know, um, it's sort of hard to scroll like that way, but it's giving all the data. But then, it's just a report, a point in time report. I can also export it to zip file, and then I have all of this data in the zip file that I've calculated in the tables. Okay, and you can see that I can actually export also individual tables. So here's our grouped 58 row table, which is already grouped, so it's really small. So I can actually export it straight to CSV here, right? There it is. And I can go ahead and open that in Excel or whatever, right? Yeah, whatever. Yeah, it's just showing you the report here. So we can open that in Excel, whatever. I will actually open it, CSV file. Okay. Right. So here we go. It's very small because we've done most of the post processing in VQL. Okay. So just to summarize what we've done today, I've shown you how to set up 5,000 endpoints for load testing of Velociraptor. And we can see how we can actually hunt against 5,000 endpoints in a couple of minutes. And then I've showed you how to use the notebook to post-process this data very quickly to do things like stacking and grouping by, and then filtering. And I've also shown you how you can work in stages. And that is actually a really powerful technique because we did some data reduction. We went from a lot of data to less data and less data. So each step in the process, we're actually is very quick. We are reducing the amount of data that we have to deal with each time. We created a smaller data set, and then we are applying a query on the smaller data set, and we are able to post-process it in stages, and that is very quick. We can then, essentially work very quickly that way, and then we can see how we can isolate the malicious tasks immediately. Okay, so that's it. If you'd like to if you'd like to learn more about Velociraptor, check out our GitHub and download it and play with it. Thanks.